Welcome to Future Not Bank once again, my dear viewers. Today I am taking most important topic of the 10th class science, refraction, in the two parts. Today I am giving the very important topics. In the next part, I am going to explain the completely ray diagrams of this refraction, including the rules of refraction also. So this today, what are the important things of the refraction definitions and refractive index, and what is the behavior of the refractive index also I am giving now. So try to concentrate more neatly and see here, first of all, what is a refraction? That is a main term, you have to know it. What is a refraction? Reflection means bouncing back of light. You know very well. Whenever the light is falling on the wall is not going to allow the light will bounce back. The bounce backing of the light is called reflection. But today's our topic is refraction. That means the light is passing easily through water, easily through glass. But what speed the light is traveling in the air or vacuum, it is not going to go that much of speed in water and glass. So what is that? What speed it is going in the air means 3 into 10 to the power of 8 meters per second. This is the speed of the light in air or vacuum. Speed of the light in air or vacuum is 3 into 10 to the power of 8 meters per second. Whenever the light is going to enter into the water or glass, the speed of the light is going to decrease 2 into 10 to the power of 8 meters. This is the speed of the light in water as well as in glass. So, because why the speed will go down in glass and water? What is the reason for going down? Means because the particles are densely packed, very closely packed. The particles in the glass, the particles in the water are closely packed. Because of the closeness, the light cannot travel that much of speed it is going to travel in air. Now, and that occasion, one trick is going to be happen. Whenever the particles are very close, light coming from rarer medium, that is called air, entering the denser medium, that is called water, light will bend. The bending of light, whenever it is going to rarer medium to denser medium, is called refraction. Now, clear example I am giving the refraction now. What is actual meaning of the refraction means the process of changing the speed when the light ray travels from one medium to another medium. Suppose the light ray is traveling from air to glass. The speed will change from air is 3 into 10 to the power of 8 meters per second. In the glass is 2 into 10 to the power of 8 meters per second. The speed is changed or not? Changed. It is a 30 crore meters per second to 20 crore meters per second, the speed is changed. What process is going on to change the speed of the light from rarer medium, so-called air, denser medium, so-called water, is nothing but refraction. And clearly we can say refraction is nothing but the process of changing the speed of when a light travels from rarer medium to denser medium is called refraction. So that is the definition. Now my strategy is, suppose we will take one glass slab, ordinary glass. We will go for one midpoint here. We will draw one midpoint in this glass slab. Light will enter. Another glass slab also I will draw here. One more glass slab also I will draw here. First of all, whenever I am taking one glass slab, this is the air. The air is what we call rarer medium. And this glass is what we call denser medium. glass is denser medium, air is rarer medium. When light is entering this midpoint of this glass, whatever a midpoint I decided here, that midpoint we call normal. The midpoint we call normal. So when the light ray, one light I am sending here, we will suppose with the angle is 30 degrees. The angle 30 degrees, one light ray I am sending. That light ray is called incident ray. That light ray is called incident ray, making an angle 30 degrees. Here, what will happen after entering into the glass surface? The surface, the entrance of the glass surface between the air and glass, whatever the entrance is there, the middle region, that is called interface. Interface means the portion where is the denser medium starts, rarer medium ends. రేరర్ మీడియం అయిపోగానే ఇక్కడ డెన్సర్ మీడియం గ్లాస్ వస్తుంది కదా, ఆ మధ్యలో టచ్ అయ్యే మూమెంటే వి కాల్ ఇంటర్ఫేస్. సో దిస్ లైట్ ఎంటర్స్ హియర్, ఇట్ ఈస్ మేకింగ్ 30 degrees. ఆఫ్టర్ ఎంటరింగ్ ఇన్ ద గ్లాస్, దిస్ లైట్ రే bends very close to the normal. This light ray, whatever the light ray is sending, that is entered in the glass, but the angle became 20 degrees. The angle became 20 degrees. That means here angle is, this is called, the light is refracted here. Whenever the light is entered in the glass, you can consider this is the refracted ray. What is we call? Refracted ray. And the angle is making by refracted ray is called refracting angle. Refracted angle. So here refracted angle is angle of incidence is greater than refracted angle. Why? Because it's 30 degrees, it is 20 degrees. Whenever the any light ray which is passing from air to denser medium, the light ray bends towards the normal. This is the first behavior of the light ray. Now, second behavior. I will draw normal here, midpoint of this one. This is the glass, denser medium. This is the air, rarer medium. Now this time, light ray is coming from denser medium. In the last occasion, light ray came from the rarer medium to denser medium. Now light ray is coming from denser to rarer medium. This occasion, here angle is 30 degrees, you think. Here the angle is 40 degrees. Now it is angle is increased. Why? Because now the refracted ray is going away from the normal. When the refracted ray will go away from the normal, when the refracted ray entering from denser medium to rarer medium. The refracted ray entering from denser medium to rarer medium. Denser to rarer medium, that time the refracted ray will go away from the normal. When the light ray is coming from the rarer medium to denser medium, the refracted ray will come closer to the normal. Now what will happen? Angle of incidence is less than angle of refraction. Why? Because this is 30 means it is 40. Now, one more behavior. Now normal it is there here. Now what I am doing here, this is the rarer medium air, this is the denser medium. Now light ray is passing through the normal. Whenever the light ray is passing through the normal, even though light ray is entered into the glass, it never bends. It never bends. Without bending, the light will enter into the glass. Undeviation. Without deviating, light ray is not going to be bent. Light ray will bend from air to glass. Light ray will bend from the glass to air. But light ray never bends when it is coming on the normal. When the light ray is coming on the, passes on the normal, it is going without any bending. without any refraction. This occasion, angle of incidence is equals to angle of refraction, that means 0 degrees. No angle is forming in this case. This is the three types of behavior when the refracted ray is there. So first behavior, once again I will repeat you, when light ray is entering from rarer to denser medium, the refracted ray moves towards the normal. That occasion, angle of incidence is greater than angle of refraction. Second behavior, when the light ray is coming from denser medium to rarer medium, that occasion, the angle of incidence is lesser than the angle of refraction. In the third behavior of the refracted ray, when the refracted ray is, the incident ray is passing on the normal, it won't bend. Without deviation, it will go straightly. So this is the three types of behavior what we will finding in the refraction. Now we are going to learn one term, refractive index. What is the refractive index? The symbol for refractive index is small n. Actually, what is the refractive index means? It is not having units. Why refractive index is not having units means because it is a ratio of the speed of the light in vacuum to the speed of the light in medium. Once again I will repeat, refractive index is nothing but it is a ratio of the speed of the light in vacuum to the speed of the light in the medium. Example, I will give you here, n is equals to C by V. N means refractive index. C means the speed of the light in air. V means the speed of the light in the medium. So, whenever I am taking the ratio of these two, the refractive index we will get it. And for example, now the refractive index of the water is 1.33. That means the refraction is taking place in the water is 1.33 times greater than air. The refraction is taking in the water is 1.33 times greater than air. And suppose the refractive index of the diamond is 2.41. This is which is the substance in the world having highest refractive index means only diamond. Diamond is having the highest refractive index in the world, in the nature. So that is 2.41. How means? Because whenever the refractive index depends upon, I already told, the speed of the light in air and the speed of the light in diamond. So when compared to this one, the ratio answer will come 2.41. That means the refractive index of the diamond is 2.41 times greater than the refractive index of the air. Now you can see what is the relation between refractive index. This is very important question. What is the relation between refractive index and speed of the light? Speed of the light. Here, what is the important point here? Speed of the light you know very well. That is the 3 into 10 to the power of 8 meters per second. And the relation means whenever the refractive index is high, whenever the refractive index is high and speed of the light will be low. speed of the light will be low. That means in the diamond, refractive index is high. So automatically in the diamond, the speed of the light is very, 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 very low when compared to the other areas, water and glass. So this is the relation. If refractive index is more, speed of the light is low. And the speed of the light is high, refractive index is low. That is the relation which we having in both. Now, very important concept here. What is the meaning of critical angle? This is the most important topic. What is the meaning of critical angle? I will explain with the picture here now. This is the denser medium, water. This is the rarer medium, air. This is water. Now, how do we will understand the critical angle here means? Suppose one light ray is coming from water and I am sending the light ray from water here, making certain angle. It is less than 90 degrees. That angle should be acute angle. Less than 90 means it is an acute angle. One incident ray making an acute angle and coming, it is not releasing, it is not coming out of the rarer medium. It is staying there only, but after touching the interface, this incident ray is following on the interface. That means it is not entering into the rarer medium, just it is following on the interface. It is coming from denser medium and following interface. It is not coming into the rarer medium. And that occasion, what is the angle between this ray is called refracted ray. This ray is called incident ray. So incident ray after touching the interface, it has to come out the rarer medium. But it is not coming to the rarer medium and just following the interface. Whenever it is following interface, whatever the angle is forming here means 90 degrees angle. The 90 degrees is forming with the normal 90 degrees right angle is forming. So the refracted ray, whenever the refracted ray making 90 degrees angle is called critical angle. Is called critical angle. If this ray is entered into the rarer medium, we cannot call it as a critical angle. We are not going to call it as a critical angle. This incident ray, after facing the interface here, following on the interface, not releasing in the rarer medium and making 90 degrees angle to the normal, this is called critical angle. Now, I am going to explain few things over here on the chart. Now we will go for few concepts here, and here two figures you can see. One line with the kind of inverted V shape here and V shape here. Whenever this kind of symbol we got means this is we call concave lens. This symbol is for nothing but concave lens. When the arrow marks are there like this is what we call convex lens. These are the symbolic representation of both concave lens and convex lens. And try to remember the lenses having two focal lengths, two radius of curvatures always. C1, C2 are the two center of curvatures, and F1 and F2 two focal lengths. And here one double convex lens I am taking here. In this, what I am doing here, this lens is made up of three different types of materials. These three different types of glass materials, not equal, not similar. And the question is, when the convex lens is made up of three different types of materials, how many images are going to be formed here? And automatically people will confuse and think that one image may be formed like that, they will say, but three different images are going to be formed here. The reason for this one is means each and every medium having separate focal length. Due to that reason, they will form the three images. And next thing is, here we can see this is the denser medium, a swimming pool. This is the denser medium, a swimming pool, and your friend is standing on the base of the swimming pool, and his height is suppose 5.6. His height is 5.6, and you are swimming in the water. You are swimming in the water, and you want to see your friend from this denser medium. You want to see from your friend means the question is, your friend appears normal 5.6 height or more than that or less than that. He will be looks like a shorter or taller or equal, means one biggest beautiful answer you will get, he will appear taller. What will be the reason means, when the person when you are swimming yourself in the water, the light ray which is coming from your eye, the light ray is coming, it is maintaining the speed of 2 into 10 to the power of 8 meters per second. After reaching the top surface of the water, that is called interface, it will enter into the rarer medium air. Immediately, the speed of the light ray which is developed from your, which is originated from your eye, entered into the rarer medium. Rarer medium is nothing but air. The speed of the light is 3 into 10 to the power of 8 meters. The speed is increased because of the high speed. Going to the normal height, it will go into the extraordinary height here. So your friend looks taller than his original height. Instead of the 5.6, he looks like a 6.6. So you will be almost taller. That is because the concept of refraction in this case. And this is the one example. Now here two lenses I am keeping. One lens is called lens L1, another lens is called L2. Here I am sending one parallel beam. So many rays are there, means they are parallel to each other. The parallel beam is entering means the nature of the convex lens is it has to converge. In the next part I will say why this, I will show the picture also, why this convex lens is converge, why this concave lens is diverge. With the pictorially representation I am giving in the next topic. But now this parallel beam after entering into the lens, they converge here, meeting at single point. Thereafter again it is getting diverges, and I am keeping one more lens here. The diverged beam again going into the parallel. This now that means the light rays are started as a parallel, ending as a parallel. Once again, the light ray here started as a parallel, ending as a parallel. This kind of concept, this kind of phenomenon we want to see. What to do? Means we have to add, we have to sum of the what is the focal length of the first lens, what is the focal length of the second lens. We have to add. Suppose the focal length of this one is 15 centimeters, this one is 15 centimeters. 15 plus 15, 30. The distance between these two lenses we must keep 30 degrees, 30 centimeters. Then this kind of phenomenon we can observe easily. That means f1 plus f2 is the distance should be maintained between the two lenses. So this is the concept. Now comes the point of the very important concept in this case here. One glass vessel and one glass jar I am taking. In this jar, 75%, 3/4 of the jar I am filling the water. That water should be crystal clear, completely transparent. And here I have one black stone I dropped here. What is my aim for this experiment means, let me know the convex lens. Suppose the known focal length of the convex lens is 15 centimeters. And if the lens is kept in the water, the focal length will decrease or increase or remain same. These questions may arise. Increase or decrease or remain same. To know this phenomenon point of view, we are conducting this experiment. And here, what is that means? It is filled with 3/4 of water. I am taking the handle of convex lens, holder, and I kept the convex lens here. Already you know the focal length of the convex lens is 15 centimeters. That means with that lens, the image we can see, the object we can keep 15 centimeters away from the lens. Automatically that is the focal length of the convex lens. And now I tried my best to keep the this lens, and the distance of the stone should be 15 centimeters. That means originally the focal length of the lens. But the image of the stone is not getting clear. Blurred image I am getting. Same black stone take outside and keep here outside this one, and if you keep the distance between the lens and the black stone, it will appear 15 centimeters in the air. In the air, the lens and the black stone distance should be 15 centimeters, and the crystal clear image is going to, perfect image I am going to appear. Then I confirmed the lens which I got is 15 centimeter focal length. I am trying the same experiment in the water. It is not coming. I am keeping the distance 15 centimeters between the black stone and the mirror, means the black stone image is blurred, not clear. So I raised from 15 to 16 I raised. Some blurredness come down. And 17, still blurredness is there. And 18, now we can see crystal clear vision of the black stone which is there in the water. Now what happened here? Now the focal length of the lens is changed to from 15 to 18. 15 to 18. That means whenever we will immerse the convex lens in the water, the focal length is going to be increased, not decreased, not remains same. It will be increased. Here the focal length is increased 3 centimeters. So this is a very good experiment in this case.